Hello, good morning students and welcome back to another video for the class 10 light chapter. So in the previous video we talked about the sign convention for solving the numericals, and of course for that we need a formula. So there is a formula, that is a mirror formula, that gives us the relation between the distance of the object, the distance of the image and the focus point. So if you have either two of these things, then you can find the third one. So let's say if you are given the object distance and you are given the focal length of the mirror used, then obviously you can find the distance of the image where it will be formed. And this formula in particular is really important in such a sense that it can give you idea where the image will be formed, and you already know the previous cases for a concave and a convex mirror. So let's take something. First of all, this is our concave mirror and this is a convex mirror. We studied about sign convention that everything on the left hand side on the x-axis is negative and everything on the right hand side of the x-axis is positive. And this is not just for a concave mirror, for any mirror, even the plane mirror also. So over here in this case of convex mirror as well, everything on the left hand side on the principal axis is taken as a negative distance and everything on the right hand side on the principal axis is taken as positive distance. So you might have guessed already that we have focus point on the left hand side for a concave mirror, and therefore the focal length of the concave mirror is always negative. I repeat once again, the focal length of a concave mirror is always negative. Concave mirror, focal length always negative. Focal length is always negative. Okay. Similarly, for a convex mirror, the focus point is on the right hand side of the mirror, and therefore it is on the right hand side of the principal axis, and thus it is always taken positive. So focal length of convex mirror is always positive. So I repeat once again, the focal length of a concave mirror is always negative and focal length of a convex mirror is always positive. But one thing is similar for both of those, that is the object distance. You always keep the object on the left hand side of the mirror. It can be anywhere between F and P, between F and C, on F, on C, or beyond C at infinity. Wherever you want to keep the object, but object will always remain on the left hand side of the mirror, whether it is concave mirror or convex mirror. On convex mirror you don't have anything to give the position of the object, but still it is always kept on the left hand side, and here as well. You can keep the object anywhere on the principal axis, but always on the left hand side of the mirror. And once again, because the object is always kept on the left hand side of any mirror, the object distance is always negative. I repeat once again, the object distance is always taken as negative. Okay? So I will write over here the object distance is always negative. Always negative. Same is for this one. Object distance is always negative. Object distance is always negative. Now, in both the cases, the image formation will be different. So we'll talk about that while solving the numericals. But now let's get on to our formula for today, and the topic is mirror formula. So the relation between object distance, image distance and the focal length is given by this formula, that is 1 upon F is equal to 1 upon V plus 1 upon U. This formula you will have to learn, and remember very carefully, because after this particular point we will be moving on to numericals, and after solving the numericals we will be moving on to the lenses. Once again we will have concave lens and convex lens. In that case, once again we will have lens formula similar to mirror formula. So don't get confused and focus more on the mirror formula for today. Okay? So mirror formula is 1 upon f, this is small f, okay, that means focal length, is equal to 1 upon v, that is image distance, plus 1 upon u, that is object distance. Okay? Okay students, so similarly how we studied the mirror formula, there is another formula which is known as magnification formula. In this particular formula, you will be able to find whether the image that is formed by the mirror is enlarged or diminished. Okay? And for this, we have that height of the object is given as height of object is given as h, and height of image is h dash. Simple. Whatever we studied in sign convention, same values are over here or same variables are used. If the height of image is smaller than the height of object, then the image is known as diminished image. And if the height of the image is more than the height of the object, then it is known as enlarged image. Okay? But what happens if the height of object and height of image is same? Then there is no magnification, neither diminished nor enlarged, because they both have the same height. So there is no magnification. Okay? And for this we have a simple formula, that is magnification m is equal to h dash upon h. Quite simple. Okay? Magnification is given by h dash upon h. Okay? You will understand these values once we start with the numericals, and this magnification formula is also given by the distance of the object and the distance of the image as well. So we have once again magnification m given by minus of v upon u, this simple formula. So if you have image distance and if you have object distance, once again you can find the magnification, and this magnification and this magnification will be same. Okay, so if you are supposed to find whether the object will be enlarged or not, okay, if the object will be enlarged or not, then what will happen is this formula can also be used without the values of height given. Okay, so let's say that the height of the object and image is same. Let's say that the height of object is given as 5 centimeter, and somehow you are getting height of image as 5 centimeters as well. Then finding the magnification, magnification m is given by 5 centimeter upon 5, height of image upon height of object. So it is given as 5, 1. So you get the magnification as 1. Whenever the magnification is 1, then there is no magnification, which means that the object is neither, so the image is neither enlarged neither diminished. So if you get the magnification as 1, then the image is not enlarged or not diminished. So there is no magnification. Now let's change something over here. Suppose we have the height of the object as 2 centimeter and the height of image as 3 centimeter. So obviously the image is enlarged. We have height of object as 2 centimeters and height of image as 3 centimeters. Okay. So let's find out magnification once again. So height of image upon height of object. So height of image is 3 centimeter and height of object is 2 centimeters. Once you solve this, you will get the answer as 1.5. You can see that now magnification is more than 1. Whenever the magnification is 1, that means the ratio is same. There is no magnification. The height of the object and image is same. But if the magnification is more than 1, that means it is an enlarged image. Suppose the case is reversed. Let's say that the object is 3 centimeters and the image is 2 centimeters. So you solve the magnification once again. So you get 2 upon 3. And once you solve this, you get 3, 1 and 3, 6, 18. So you will get 0.66 magnification. Now, because this is in decimal places, which means that this number is smaller than 1, this number is greater than 1. Whenever you get the magnification less than 1, it means that the image is diminished. That means diminished than the object. And if you get the magnification more than 1, that means the image is enlarged, larger than the object. Quite simple actually. And this will be very helpful once we solve the numericals in both the cases. Okay, we will solve the example using both of these cases. Okay students, so a numerical for you based on the mirror formula, and this will clear many things for you while solving the numericals. If an object is placed 10 cm from a convex mirror of radius of curvature 60 cm, so you have been given the object distance, that is 10 cm from a convex mirror. Okay, convex mirror means this one. Okay, and its radius of curvature is 60 centimeters. That means if you draw a small and rough ray diagram, radius of curvature is over here and this distance is 60 centimeters. And you know that the object is always in the left hand side, like I said just now. That means the object is placed somewhere over here like this. Okay, and that distance is 10 centimeters. Understood? But whenever we are using a mirror formula, you are not using the radius of curvature. Okay, find the position of the image. So this is a convex mirror. You know that in a convex mirror, image is never formed on this side. It is always formed virtually inside the mirror. Okay, so the image will be formed somewhere over here. Why? Because center of curvature is over here and the focus point is somewhere over here, because we know that radius of curvature is twice the distance of focal length. I have taught you this in the previous videos, that focus point is in the exact middle of radius of curvature. That means this part and this part are equals. That means 60 centimeters, you are going to do half of it in order to find the focal length. So this is your focal length over here. Okay, so r by 2 is equal to focal length, and therefore focal length is equal to what is radius of curvature? 60 centimeters given to you, divided by 2, this will become 30 centimeters. Now you have everything, you can apply the mirror formula. Quite simple actually. 1 upon f is equal to 1 upon v plus 1 upon u. Focal length you have 30 centimeter, and because the focal length of the convex mirror is on the right hand side, you have to take this as plus 30 centimeters. Okay, this is equal to 1 upon v. You are supposed to find the image distance, so keep it as it is, plus what is your u, that is 10 centimeters. So you are writing 10 centimeters over here. But we know that object is always on the left hand side of the principal axis, on the left of the mirror. So it is always taken as negative, that is on negative x-axis. So this plus and minus, this will become minus 10. So what you get over here is plus 1 by 30 is equal to 1 by v minus 1 by 10, because the plus minus sign becomes minus 1 by 10. You are supposed to find 1 by v. So you take this whole number on that side of the equal to sign. So the minus sign changes to plus sign. So it becomes 1 by 30 plus 1 by 10 equals 1 by v. Now this is simple addition of fractions. So 30 is the LCM, multiplying this by 3 and this by 3. What you get is 1 plus 3 upon 30, because 30 and 30 LCM is same. This becomes 1 by v. Therefore, you get 1 by v is 3 plus 1, 4. So 4 by 30. But remember, you are not supposed to find 1 by v. You are supposed to find v by 1. That is, you are supposed to do the reciprocal. So v is equal to 30 by 4. Table of 4, 4 7 28. 2 is remaining. So the decimal point, 4 5s are 20. So what you get, v as 7.5 centimeters. So now let's check our ray diagram, that is over here. This is our focal length and and its distance is 30 centimeters. And what is the image that we are getting? 7.5 centimeters. That means from the mirror, the image will be formed somewhere over here at a distance of 7.5 centimeters. So as you know, like I said in the ray diagrams, that the image will always be between pole and focus. Listen, you are not supposed to draw the diagram in the examination or in a notebook unless you are asked in that question. Okay, but in this case, this is your first numerical, and whenever you are practicing, it is always better to draw a rough ray diagram. Okay, so you get the idea of how to solve the numerical and whether you are making any mistakes or not. Let's say by chance you made a little bit mistake over here in this numerical, and somehow you are getting the answer as minus 7.5. Suppose you forgot to change the negative sign over here, and whatever minor mistake you made, and you are getting the answer as negative. If you are getting the answer as negative, which means that your image is formed somewhere over here, which is not possible in a convex mirror. So the answer whichever you are getting is your key to check whether the image or whether the image formed is in a correct position or not. And in this case, we are getting 7.5, which is less than 30 centimeters. Okay, so the image is between pole and focus, and it is positive, which means it is behind the mirror. And thus, you get the idea that whatever answer you are getting is correct. I hope it is clear to you, students. Till then, have a nice day.